Module 8 quiz review, we're going to go over the concepts from sections 1, 2, and 3. So section 1, we just talked about the types of data. So there are two main types of data, quantitative and qualitative. So quantitative data is data that is represented with a number. So for example, that can be height, age, shoe size, and weight. These are just a few examples. Obviously, there are an infinite number of examples of things that can be represented with a number. On the other side of things, we have qualitative. And qualitative data is something that it describes characteristics. Okay. So examples of some qualitative data are color, and that's color of just about anything. Eye color, hair color, car color, anything that has color in it. There's also names, and this is not just people's names, but it can also be names of things, names of brands, names of cars, like, again, anything that has a name to it. States, so if we were to collect data on states you were born in, states you've lived in, states you've visited, that would be qualitative. And then lastly, your grade, not just the grades you are in school, but the grades you earn in your classes, because those are represented, not your grade you're in, but the grades you get in your classes, because those are represented by letters, A, B, C, D, or F. Next, we have discrete versus continuous. Discrete and continuous is specific to quantitative data. So something can only be discrete or continuous if it's specifically something that's a number. Discrete is values that can be counted. Okay, so for example, the number of students in class, that's something you count. Also, flipping coins, you can count the number of heads you get, the number of tails you get, and then lastly, rolling dice, because again, you would see if you got 1s, 6s, something like that. Okay. Whereas continuous data are values that are measured. Okay. So for example, that can be weight. You measure someone's weight. It can also be height. We can measure people's height. Time. So either times it takes you to run something, time it takes you to get to school. There's a lot of different things that we can measure for continuous data. Next, we talked about whether something is represented by a binomial probability distribution. In order to figure that out, there are 4 questions you have to go through and ask yourself. And the answer to all of these questions needs to be yes. So the very first question you need to ask yourself is, are there a set number of trials? So are you going to flip a coin 10 times? Are you going to ask 100 people? Are you going to draw a card from a deck of cards, because there are only a certain number of cards in a deck? Okay. The second question is, are there only 2 outcomes. Okay, so if I flip a coin, there are only 2 outcomes, heads or tails. If I want to ask someone, have you ever been to Florida? That's a yes or no question. So it can sometimes be a yes or no question most of the time. Other times it could be heads or tails, but usually it's yes or no. Okay. The third question is, are the outcomes independent? So if I'm going back to the flipping coins example, if I flip heads the first time and I want to flip the coin a second time, is that outcome independent of whether or not I flipped a heads the first time? And the answer is yes. I'm not gonna, just because I flipped a coin once and got heads doesn't mean that I have to get heads on a second flip or I can't get heads on a second flip. Those outcomes are independent of each other. Okay? And the last question you want to ask yourself is, does the probability of success remain the same for each trial? So again, I'm going to go back to the flipping a coin example. So is it always 1/2 to flip a head on a coin? And the answer is yes. Each outcome, there's a 50% chance of flipping heads or flipping tails. If you're going to get no as an answer, no as an answer is most likely going to come from either question 1 or question 2. Okay? Question 3 and 4 are almost always yes for any type of situation I may give you. It's not always, but almost always. So if you're going to run into a no, it's going to be in something like question 1 or question 2. So section 2, we talked about mean, median, mode, and standard deviation. So the first I'm going to calculate mean, median, and mode. So if we want to calculate mean, median, and mode, I'm going to start with mean. So to calculate the mean, you're going to add up all of the values and divide by the total amount you have. So we're going to do 12 plus 8 plus 6 plus 5 plus 5 plus 4 plus 15 divided by 7, since there are 7 numbers in our data set. Okay. When I add up all of my numbers in my numerator, we're going to get 55 divided by 7, which is approximately 7.857. So median is the middle of your data set. In order to find the median of a data set, you have to list it in order. So my first step is going to be to relist all of my values in order. So 4, 5, 5, 6, 8, 12, 15. Then you start crossing off each value starting from the ends and working your way towards the middle. Because we have an odd number of values, there is going to be a number that's in the middle, and that's 6. If we'd had an even number of values in our data set, the 2 we narrowed it down to, we would have added them together and divided by 2 in order to get the middle. Okay. Lastly, we want to find the mode. And mode represents most, so the number that occurs the most. And in this case, the mode is 5, because that's the only number that appears more than once. You can have more than one mode. Mean and median, you can only ever have one of. So if you're going to see something that has more than one answer, the only time it can happen is with the mode. Next, we want to calculate standard deviation. So from the notes, standard deviation, we do the sum of the square root of x minus x bar squared over n minus 1. And I always like to break this up into steps. I find it's easier if I break it into steps to calculate. So first I start by listing all of my x values. They do not have to be in any order. You just list all of the values you have in your set of data. Okay. Next, I list the mean, and I usually only list it once because the mean stays the same for every single data. Okay. Next, I'm going to take each value x and subtract the mean from it. So 12 minus 7.857 gives me 4.143. Do the same thing with 8 minus 7.857 gives me 0.143. I'm going to do that for each data in my set. So next we get negative 1.857, negative 2.857, negative 2.857 again, negative 3.857, and lastly 7.143. Next, we want to square each of these values. The important thing is when you square a value from the previous column and it's negative, you have to put that value in parentheses. Every value in the x minus x bar squared column should be positive. If you don't have a positive value, you didn't put it in parentheses. So when I square 4.143, we're going to get 17.164449. When we square 0.143, we're going to get 0.020449. And I'm going to keep working my way down the list. So next we get 3.448449, 8.162449, 14.876449, and lastly 51.022449. I did write every decimal place because I want my answer to be as accurate as possible. Anytime you round, your answer gets farther and farther away from the actual value. So I did have to round with my mean, but notice how I used 3 decimal places so I could be more accurate. And then every step forward, I kept all of the decimal places so I'm staying as accurate as possible. Now obviously, if your mean is only 1 or 2 decimal places, you can use that. But we are never, ever, ever gonna round in the last 2 columns to a whole number unless the answer is already a whole number. So if you have a decimal in either the x minus x bar or x minus x bar squared column, you must keep it as a decimal. No rounding to whole numbers. Our next step is now going to be taking the sum of that x minus x bar squared column. So I'm going to take all of those values and add them together. When we add all those values together, we have 102.857,143. Okay. I now want to take that value, and now's where I do the underneath the square root part. So I want to do the square root of the summation of the x minus x bar squared. So 102.857,143 divided by n minus 1. So n minus 1 represents the number of data you have minus 1. So we have 7 pieces of data. When we do 7 minus 1, we're going to get 6. So in a calculator, I do the division, we take the square root, and we get a standard deviation of 4.14. Okay. When you get to the final answer, you are allowed to only write 2 decimal places. The final answer for standard deviation, it's perfectly okay to leave it as 2 decimal places. Okay. So last thing, section 3, correlation and regression. So this relies heavily on Desmos for calculating actual lines of best fit and calculating the correlation coefficient. So in order to insert this table into Desmos, we're going to hit the plus button in the top left table, then we're going to, in the top left, then we're going to select the table feature. So once you select the table feature, then you go ahead, you list all of the x values, then you go over and you list all the y values. Now to get the line of best fit. Okay. On a new line, you're going to type the equation y, then a 1. It will automatically write it as a subscript in Desmos. The little curvy button, and on your computer that you can get that by doing shift and then the button next to the 1. Then we do mx1 plus b. It's extremely important you type this equation exactly as how I've written it in Desmos. If you don't type it exactly like this, you will not get the correct answer. Once you do that, there should be some values that show up directly underneath this equation. So that's how we get our actual equation. So do y equals, then we look for m, which represents the slope. I usually round to 2 decimals, so my slope ends up being 1.67x plus, then we look for b for the y-intercept, 1.63. When we actually go to write the equation, you don't have to put y1, x1 anymore. You can just leave it as x and y. The last thing is to find the correlation coefficient and discuss its strength and direction. So we look for r. So in this case, r equals 0.9899. So the strength. So we look to see if it's strong or weak. So strong is any value close to 1 or -1. So 0.9899 is really close to 1. So it's strong. Okay. The direction is whether or not it's positive or negative. In this case, 0.9899 is positive. Please let me know if you have any questions over sections 1, 2, and 3, and if you have not completed all of the assignments yet, please do that as well, and we can always schedule a time to do them together if you need help.